Both of these mean the same thing. So it could say absolute max or it could say global max. But what that represents is your highest point. That's your highest point. This graph has an arrow pointing up. And if you have an arrow pointing up, that means it's never going to stop rising. And because it never stops increasing, it doesn't have a highest point. Would you agree that if something is always going up, it doesn't have a highest point? So that's why we're going to say none. We don't have one of those. An absolute global minimum would be your lowest point. In this graph, we have an arrow going down. So if you're continually falling, do you ever reach the bottom? No, we don't have one of those either. Now, local max, or it could say relative max. To me, the easiest way to think of that is a hilltop. Now, the mathematical definition would be where the graph changes from an increasing to a decreasing interval. Okay, that's the mathematical definition. Where does the graph change from an increasing to a decreasing? But the Miss Bryant definition is a hilltop. There are two places where I see a hilltop, and that would be both of these. So I'm going to list both of those as a local relative max. So that would be -3, 2, and also 2, 1. And a local relative minimum, I like to think of it as a valley or a dip in the graph. And there's also two of those. And that would be here and here. So that would be -1, -3, and 4, -1. Any questions about the definitions of each one of these terms? So it could say absolute max or it could say global max. It could say local max or it could say relative max. All right, so now let's look at the next graph. Do we have a highest point? Who says yes? Who says no? I say no. No, because both sides are going to continually increase. So I'm going to say none. You could also say NA. Do we have a lowest point? We do. Now this point here is my absolute minimum, but every absolute is also a local. So I'm going to list that point twice because it's the lowest point, but it's also a dip. So I'm going to put the point 1, -1 in both of these plots. Yes.
The other one didn't have a minimum, but it also had a loose point.
So that's a good question. So let's go back. The reason why this one doesn't have any absolutes is because the arrows are going in opposite directions. One side is going up, 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 up. The other side is going down, 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 down. And I don't know if you remember this from Algebra 2, but we call that an odd degree function. Odd degree functions have arrows that go in opposite directions. If it's odd, you will not have an absolute anything. But this graph is even. They're both going in the same direction. So we will have either an absolute max or absolute min. Okay. So we don't have a absolute max, but we do have a local max because there is a spot where there is a hilltop. And that is about here. It's a little bitty hill. It's not a big hill. It's just a little tiny hill. That would be called a local max. And that point is approximately at 3, 1. Is there any other place on this graph where you see a dip? Yeah. There is one more place where there is a dip or a valley, and that would be right here. This would be called a local min. It's not the lowest point, so it's not an absolute min, but it is a place where the graph changes from decreasing to increasing. So we're just going to approximate that red dot. So what would be our approximate order pair? What are we going to call that point? 4 what? 4.8. That's what I heard. And you have a lot of flexibility in that and how you want to, because we can't like say what it is exactly. But we know that it's somewhere between 0 and 1. So that's an approximation. Any questions? None? Well, let's look at the next graph. All right. This is another even degree. Both arrows are going in the same direction. Do we have an absolute maximum? Yes. There are 2 hilltops. Would you agree that there are 2 hilltops? But one of them is higher. So I'm going to list this point in 2 different places. This is going to be my absolute max, and it's also my local max. So we got to approximate that. So somebody tell me, what are we going to call that point? 475. That sounds good to me. It's not exactly 475, but you know, we close. 475 is going to go here, and it's also going to go here. All right. Do we have a lowest point? If you have an arrow going down, then you don't have a lowest point. Both sides are going to continually fall. So we're going to say none. Now, are there any other hilltops in this graph? Yep. All right, somebody tell me this point here is another hilltop. So that would be a relative max. Who's going to tell me, what would be the point? What are we going to call that? Negative 225. Do we have a relative minimum or a dip or a valley? We do. And that is going to be right here. What are we going to call that point? $130? -30. I'll go with -30. And that's it. That is what you're going to do on your quiz next week. Any questions? All right, we got one more graph. Go ahead, let's look at this one. So this is an odd degree. because arrows are going opposite. So I already know that this is none. One side is going up and the other side is going down. So we don't have either one of these. Show me with your fingers, how many local maxes do you think we have? All right, I agree, it's 2. We have one here and we have one here. So if I were to approximate it, I'm going to call this one, I'm going to call it negative 1.54. And then the second one, I'm going to call that one 210. And again, you just have to be in the neighborhood. We can't say the exact numbers. And then show me with your fingers, how many local relative mins do you think we have? All right, 2 again. That would be here and here. So I'm going to say that's negative 3, negative 2. And then I'm going to call this one 1/2, negative 1. All right, last thing we're going to talk about, and we'll finish this tomorrow, but I want you to have all the information so you can at least attempt to do everything on the study guide, okay? So the last piece that's on the next quiz is rate of change. Now, I think that this is confusing to most people. Most people don't recognize what this is. But what this is saying in a mathematical way is y2 minus y1 divided by x2 minus x1. Does that formula sound familiar? The formula for how to find the slope of a line? So I'm going to write it that way. This is how you find rate of change is slope. You need to know this formula. So I'm going to give you a minute to copy down this example. So this is example 4. This is your equation, and then go ahead and copy that down. And then we'll talk about how to find the rate of change. I'll zoom back out in the end. So when you see this on the test, I'm always surprised how many people miss this question, because to me, I'm like, this is algebra 1. How to find the slope. y2 minus y1 over x2 minus x1. So let's talk about what this means. First of all, the numbers in this bracket, this is your x1 and your x2. That's what those two numbers are. So the first thing you need to find is your y1 and your y2. How do you think I'm going to find y1 and y2? What am I going to do with these numbers? If I want to know what y is when x is -1, how do I do that? Substitute it. So what I want you to do first is find h of -1. And then you're also going to find h of +1. So h of -1 would be -1 squared minus 2 times -1 plus 3. And then h of +1 would be +1 squared minus 2 times 1 plus 3. All right, so let me zoom back out. Go ahead and find both of those numbers. Okay, so we got 1 plus 2, which is 3. 3 plus 3 is 6. So we should have 6 for the first one. For the second one, I have 1 minus 2, which is -1, and -1 plus 3 is +2. So who had both of those numbers? Who had that? Okay, so I'm going to write this as order pairs. So what I have is I have the point -1, 6, because when x is -1, y is 6. So we're going to write that as an order pair. And then my second order pair is +1, 2. Because when x is +1, y is +2. So this would be my x1, y1, and my x2, y2. Now we can find the slope. So go ahead and substitute in those numbers into the slope formula. You do need to know this formula. I'm not going to give this to you on the test. So when I substitute it in, I get that m equals y2, which is 2, minus y1, which is 6. And that's over x2, x2, which is 1, minus x1, which is -1. So slope equals 2 minus 4 is -4. And when you subtract the negative, remember this becomes positive. So 1 minus -1 is the same as 1 plus 1, which is 2. And -4 divided by 2 is -2. That would be my answer. That is the rate of change.